Hi guys! So here I have written down some examples of the last few types of derivatives that you learn how to do. One of these is the inverse trig functions, like secant inverse that I have written here. You can just memorize formulas. They have usually the 6 formulas listed in the calculus books, but there is a different way to doing this other than memorizing, which is what I'm going to show you. So with the secant inverse, the first thing you would do for this alternate method is switch this argument right here with the y. So when we do that, we get to get rid of this little -1. We basically are getting rid of the inverse when we do this. So I rewrite this as 3x squared equals just secant of y. Now that I have it written this way, I can just take the derivative the normal way, although it will be implicit because the y is not alone. But I start taking the derivative, so I get 6x equals, and the derivative of secant is secant tangent, so I'm going to have secant y tangent y times dy dx, because I had to do this implicitly since the y wasn't alone. So to get dy dx alone, I divide both sides by secant tangent. So secant y tangent y on both sides. All right, so right now dy dx is equaling 6x over secant y tangent y. Now the only problem is I can't have y's in my answer because this wasn't really an implicit problem. I just turned it into that. So what we do is we go back up. This is the key equation right up here, this equation. We can draw a triangle that shows this relationship that's written in that equation. So this equation is saying the secant of y equals 3x squared. The y you can call this angle right here. Now remember, secant is hypotenuse over adjacent. So if it's 3x squared, think of that as 3x squared over 1. So the hypotenuse would be labeled 3x squared. The adjacent would be labeled 1. Now we just need to come up with what this missing side is. I'll get rid of that arrow. So we're going to figure out what this missing side is by using the Pythagorean theorem. So to get this question mark, I'm going to say, well, 1 squared plus, let's call it b squared, equals 3x squared squared. And then just isolate the b squared. So 1 plus b squared equals 9x to the 4th altogether. So subtract 1, b squared will equal 9x to the 4th minus 1, and then just take the square root of both sides. So this is what b equals. It's the square root of 9x to the 4th minus 1. And that's the question mark. So this, right, I'll erase this question mark. And this side can now be labeled radical 9x to the 4th minus 1. Now, the reason this triangle helps us is because now we can remove from our answer the secant of y and the tangent of y by writing down what they are from the triangle. So I'm still going to have 6x on top, but looking at the triangle, well, we knew that the secant of y was 3x squared. But that's because it is hypotenuse over adjacent. So the secant of y is just 3x squared. Now the tangent of y is opposite over adjacent. So that's just going to be the radical of 9x to the 4th minus 1. Because the adjacent is just a 1, so we don't have to write that. So that is our final answer for dy dx for this problem. Now, like I said, you can also memorize the formula for secant inverse and all of the other ones, cosine inverse, sine inverse, and do it that way. But this is an alternate way. Now number 2, we're doing the derivative of a logarithm. So the formula for this, dy dx, is, all right, this is part of the formula. The base, which is 4, we write the ln of 4 in the denominator, times, and we also write the argument of our logarithm in the denominator, so 5x cubed. And then on top, we write the derivative of 5x cubed, which is 15x squared. And that's our answer. We could reduce this a little bit, though. The 5 goes into the 15 3 times, and then this x squared will cause this to be just an x. So our final answer would be 3, and it's probably good to write the x first in front of the ln, because you don't want someone thinking it's the ln of 4x. It's just the ln of 4. So this is our final answer for that. Now, we have an exponential problem. So dy dx, when we have an e in the derivative, you have exactly the same e again. So e to the tangent of x to the 4th. Then you have to multiply by the derivative of the power. So I know that the derivative of tangent is secant squared. So I will first have secant squared of x to the 4th. But then because of the chain rule, the derivative of x to the 4th is 4x cubed. And we can just circle this. This will be our answer. There's really not much simplifying you could do anyway for that. All right, and then the final problem I have picked out is a little bit harder. This is the kind where you have x in the base, and it's also raised to an x in the power. And when you have that, you can do what I'm about to show you, which the first step is to take the ln of both sides. And from there, I think it will kind of make sense. So our first step is to write ln of y equals ln of x to the sine of x. Now the second step is always going to be the same. Bring the power down. And that's just a property of logarithms. We can take this power and stick it there. So ln of y equals sine of x, ln of x. Now, we're going to take the derivative of everything, but we have to do it implicitly because the y is no longer alone. So the derivative of natural log y, that is just 1 over y. But then we also have to multiply by dy dx, because that was a y and we're doing implicit. Now on this side we have to use the product rule, so think of this as u and that as v. So we're going to do u prime times v plus u times v prime. So u prime, the derivative of sine is cosine, times the v, which is still just ln of x, plus the original u, so that's just sine of x, and then v prime, the derivative of ln x, is 1 over x. And then we're pretty much done. We just need to isolate the dy dx, so just multiply both sides by y, like this whole thing, times y, because then that will cancel. Now one thing we can do all at once is, when you get to the y, right here, instead of just writing the letter y, write what it was equal to. Because in this problem, this type of problem, we know that the y was x to the sine of x. So we get, for our final answer, cosine of x times ln of x plus sine of x times 1 over x, all times x to the sine of x for your final answer. And if you think about it, in problems that are implicit from the beginning, you never know what the y is at the end to be able to do this substitution right here, and that's fine. But when you take a problem and you make it become implicit by no longer having the y alone, then at the very end you're not allowed to leave just the letter y in your answer. You have to resubstitute what the y originally was. And that is it.